everyone, my name is Lindsay Wells and I work for the Michigan Department of Environment, Great Lakes and Energy's Air Quality Division out of our Cadillac District office. Also here with me is my counterpart Erin Sheridan, who works out of our Bay City District office. And today we're going to talk to you about the Air Quality Division's Leak Detection Program. I'm the division's point of contact for this program, and I'll be providing my information to you before we finish up, so please feel free to contact me with any questions anytime. So here's what we're going to talk about today. Erin is going to talk about the instruments that the Air Quality Division can use to detect equipment leaks and how those instruments work. I'm going to talk about why we perform leak detection, what it looks like in practicality, and how we will communicate findings to you if we perform leak detection activities at your site. So what are leak detection and repair programs? They're commonly called LDAR programs. And these are work practice standards that are designed to identify leaking equipment so that emissions can be reduced through repairs. LDAR programs generally require a site diagram and an inventory of all the pieces of equipment that are monitored for leaks. These are called components. Each component has a physical tag with a unique ID so it can be quickly identified and located in the field. Components must be monitored for leaks at specified intervals, repaired within a certain time frame, and re-monitored after repair to make sure that they are no longer leaking. LDAR programs are required by certain Clean Air Act standards. The Air Quality Division determines compliance with many of these federal standards for Michigan sources by conducting on-site inspections and reviewing records that a source is required to keep. Leaking equipment can be a costly source of air pollution and can present a safety risk, so addressing leaks is important. Now that we've talked a bit about what LDAR is, Erin is going to tell you about the instrumentation that AQD uses to perform leak detection.
Hi everyone, I'm Erin Sheridan, and as Lindsay stated, I will be touching on the technology overview portion. Currently, Air Quality Division plans to use two types of instruments during our leak detection work. The first that I will cover is our forward-looking infrared or FLIR cameras. These cameras will be used to visually identify volatile organic compound or VOC emissions. By using the FLIR camera, we can identify leaks in real time without shutting down equipment. This instrument also keeps operators safe since we can detect emissions from a distance. The FLIR camera works by picking up infrared wavelengths that VOC is naturally absorbed. When gas escapes the equipment, it blocks or absorbs background heat, so the leak shows up as either a darker or lighter plume on the camera screen when monitoring. During monitoring, we rely on the camera's high sensitivity mode, which enhances even very small plume movements and makes minor leaks easier to see. And because the camera reads background temperatures, we can choose conditions like the right wind and temperature contrast that gives us the clearest image of any potential leaks. Along with the FLIR camera, we will also use a flame ionization detector, or FID. This device gives us a direct measurement of VOCs in the air around a potential leak. To take a reading, we place the probe near the emission point, and the instrument pulls in a small air sample. That sample is ionized and charged particles are created. The instrument measures the electrical current from those charged particles and converts it into a parts per million concentration that is displayed on the device in real time. This gives us a clear quantitative way to understand the concentration of VOCs right at the source. And now I will pass it back to Lindsay to cover all things leak monitoring.
Leak definitions are rule specific. This slide has examples from a few, but not all of the LDAR rules. NSPS 3K, often referred to as NSPS KKK, has a leak definition of 10,000 ppm, whereas NSPS 40A, often referred to as Quad OA, is a newer rule with a leak definition of 500 ppm. These rules apply based on when the site was built or make certain types of changes. If you have any site-specific questions or rule questions, contact me and I can work with your district inspector to provide some guidance. This slide has some examples of the types of components that are subject to leak detection and repair. Do note that these are just a few examples and not the complete list of components for these rules. Again, if you have any questions about a specific rule, please feel free to reach out to me. So for NSPS KKK, some of those regulated components are valves, pumps, and pressure relief devices. However, in Quad OA, which is newer than NSPS KKK, the components list is expanded to also include meters and any component that may leak VOC or methane. Components are monitored for leaks at what are called their leak interfaces. And a leak interface is just anywhere that gases or liquids can potentially escape. Oftentimes, that's where two pieces are joined together and maybe where something uses a gasket or a seal that can degrade over time. We've got an example here of a pressure relief valve, and the leak points are outlined in yellow. So if you look from top to bottom, we'd monitor the cap, the drain port, the bonnet, which is a sealed cover over the part of the valve that actually opens and closes, and the connection flanges. Now we're going to talk about how AQD will identify leaks. This slide shows an FID example. The tag component in this picture is a valve, and the FID probe is monitoring the bonnet of that valve. We would also monitor the valve's packing gland and valve stem, which are located in the upper left of the picture, just to the left of that green stamp tag, which is the unique LDAR ID tag for this component. If we use NSPS KKK as our example, if the concentration was greater than 10,000 ppm, we would flag this component as a leak. We also write more information on a field log sheet, like which portion of the valve was leaking. We'll attach flags to leaking components if it's safe for us to do so. If for some reason we're unable to flag something, we'll still communicate the leak to you by writing it on the field log and by contacting you to further discuss any components that we weren't able to flag in the field. AQD will be flagging components using surveyor's flagging tape. It's shown on this slide on our example check valve, and I have a short length of it here with me also. Each flag will be numbered. Our example flag here is labeled leak number 1, and we would write additional information on the field log sheet under AQD leak number 1, such as this component's LDAR tag ID and which portion of the component was leaking. So how will you know that an LDAR inspection has taken place at your site? We've created an LDAR inspection notice card that we'll leave at the site even if we don't detect any leaks. If leaks were detected, those components will be flagged and or recorded on the field log of flagged components, and I'll show you that log on the next slide. Once we've finished the field inspection and compiled all of the information, we'll also email you an LDAR survey letter that summarizes our findings. It is important to note that AQD may not survey all of the components that are present at a site. So this slide is showing an example of that field log of flag components that I mentioned before. The field log represents our preliminary findings and is left at the site so the on-site operators know what the flags are for and to aid in their prompt attention to the equipment that appeared to be leaking. We'll send you an electronic copy of this field log once we've completed our on-site inspection, and after we've reviewed and compiled all of our data, we'll send you an electronic letter that summarizes our findings. So Erin and I want to thank you again for listening to learn more about AQD's LDAR program. Again, my name is Lindsay Wells, and I'm the AQD's LDAR program point of contact. Please reach out to me with any questions anytime. My phone number is 517-282-2345. You can also email me at WELLSL8@michigan.gov. Thanks again, and take care.